All right, so we're going to look at some basic functions, and then we're going to get into more complicated ones. Key concept. The first one is constant functions. If you have a constant function, it's just y equals. All right, so we have a constant function here. It means y stays the same. A constant function means y equals 1, y equals 2, y equals 3. So if I'm looking for a limit of a constant function asking what y is approaching, y is always going to be the constant that it always is. All right, so when I have a constant function, the limit will always be whatever that function is. They're talking about something like the limit as x approaches any number of 5. Well, that means y is always 5. So my limit is 5. Like a constant function never changes. So my y is always approaching the number that it is. Identity function. That just means a line. If you have a line or any continuous function, the limit at that point is going to be what happens when you plug it in. All right, if it's a continuous function, like a line, a linear function, then it's just going to be whatever happens when you plug it in. All right? And so they give you some properties. If you're trying to find limits, you can take the limits individually. So let's say you have a polynomial rather. So let's say we have x squared, something like this, plus 3x plus 2. You can do your limits individually and add them up, all right? You can subtract, you can do scalar multiplication of limits. You can multiply the product of limits, divide as long as you're not dividing by 0. You can have a function to a power and a root. So the first method of solving for a function limit is just to plug it in. All right, just to plug it in. If at all possible, when they ask for the limit, plug it in. If you can plug it in and there are no problems, you found your limit. That's what it's approaching. So like for this first one, I have the x is approaching -1. My x is approaching -1. This is a continuous function. There's no denominator, there's no square root to cause a problem. I can legitimately just plug in a -1. Pay attention to your positives and negatives here, but you can just plug it in. So this one's going to be that, this one's going to be that. This one's going to be that, right, and then plus, -1 plus 4, something like that. I think they tell me it's -7. -3 minus 5 minus 2 minus 1 plus 4, -7. And so this is my limit. Plugging it in works, all right? Plugging it in works.
Can you say...
If I have a continuous function, then it is approaching the number it's actually going to be. There's no jump, there's no hole, there's nothing else like that that causes a problem. So I'm going to be approaching the actual number that I am when I get there. It's continuous. So when you have a continuous function like that, or a function where there's not a problem at the what you're actually approaching, you can plug it in. So just like the handout that you had, your first function there was continuous. Your limit was what would happen if you plugged it in. If you plugged in a -2 there, you get -3. That's what your limit was. And so if you have a continuous function, you can just plug it in, because what you're actually approaching is what's going to happen, because it's continuous. It's continuously moving towards that number.
So how do we... I never asked this many questions.
All right, let's look at this next one. What are we approaching? X is approaching 3. If I plug in a 3, do I have a problem? No, there's no problem. So I'm going to plug it in. I'm going to say, all right, I'm approaching 3. It doesn't appear to have any problem, so I'm going to plug in a 3 on the top there. I'm going to plug in a 3 on the bottom here. All right, so on the top, I am going to get 48. On the bottom, I'm going to get -6. My answer here is -8. I am good. All right. Let's look at this last one. What am I approaching? 1. Can I do direct substitution here? All right, so let's plug it in. 1 squared minus 1 over 1 minus 1. What's the problem? It's a 0. So this particular one cannot be solved by direct substitution, all right? There is another method we're going to use. Direct substitution will not work for this one, all right? So for this particular example, you would say you cannot use direct substitution here, all right? You cannot use direct substitution here. So go ahead and try A, B, and C there. All right, let's look at these. Next example. So the first thing you want to do if you cannot just plug it in is say, is there a way to get rid of my problem? All right. Remember, if it's removable, there is a hole there. Well, we've looked at graphs with holes. Holes do not cause a problem with limits because it's what it is approaching. All right. And so if we can remove the problem, then we can plug it in and we can see, remember when we graphed, plugging in will tell us exactly where the hole is. That also tells us exactly where the limit is. All right. And so for this first one, they want us to plug in a -4. What's the problem? We got a 0 on the bottom. So here's what I'm going to do. I am going to factor. And I'm going to say, well, let's look at this individually. Let's look at this top and factor it. Factors of 20 that subtract to give me 1. Everybody see that? -5 and +4, right? That adds to give me -1. Multiplies to give me -20. All right, on the bottom I have x plus 4. Now, what can I do here? I can cancel. I now can say, well, let's find the limit of this one. It will be exactly to the limit of the other one. I will just have a hole here. Now can I plug it in without a problem? Yes, I can. So I have -4 minus 5. My limit here is -9. 3. They want me to plug in a 3. If I plug in a 3, I get 27 minus 27 minus 21 plus 21. That gives me a 0 on the bottom, by the way. All right? 0 on the bottom. So I am going to factor. How do I factor 4 terms? What do I do to factor 4 terms? Yeah, factor by grouping. So if you remember, to factor this guy, you are going to group it. Group the first 2, group the last 2. What happens when I group behind a negative? What do I need to do to the last term? Yeah, change it the sign. All right? So what can come out of the x cubed and the 3x squared? Squared, right? Your lowest exponent. We're left with an x minus 3. What can come out of a 7x and a 21? 7. We're left with x minus 3. All right? What can I factor out of those? What's the same? The x minus 3, right? And what's left over? X squared minus 7. All right? Everybody see that factoring? So my numerator here is x minus 3. My denominator is x minus 3. X squared minus 7. What can I do? I'm left with a 1 on top. Don't forget the 1. And an x squared minus 7 on bottom. Now can I plug in a 3? Yes. I get 1 over 9 minus 7. Which gives me what? 1/2. That is my limit. That is my limit. All right? So factoring. The first way you're going to try is direct substitution. Then you're going to say, hey, is it possible to factor it and get rid of my problem? Go ahead and try A and B there. All right, so your first step is to try to directly substitute. You can't see if you can factor. If you see a radical, you are likely going to have to use this process. All right, it is what it is. All right, we are using the concept here of, like we did when we were dividing by radicals. You're using the conjugate, all right? So wherever you have the radical, you're gonna use the conjugate of that piece. Obviously 9 causes a problem, right? We get a 0. And so what we're gonna do is we're gonna take this and we are gonna use the process of rationalizing it. It will look familiar when we do it. So we're going to take whichever piece has the radical and use the conjugate of that. So the numerator here has the radical. So we're going to multiply the top and bottom by the conjugate. It's the same 2 numbers, but we change the sign. And we're going to do this on top and on bottom. All right, on top and on bottom. All right. Now, let's look at what happens here. On the top, when I multiply radicals, remember it's just the first one squared. What happens when I square a square root of x? It's just an x, right? And it's subtracting the second one squared. What is 3 squared? It's not a trick question. 9, okay? And on the bottom, I have x minus 9 times the square root of x plus 3. What can I do? Yeah, I can cancel the x minus 9s, and I get 1 over the square root of x plus 3. I am looking for the limit as x approaches 9. Did I get rid of my problem? Yeah, right? That no longer causes a problem, does it? Yeah, so it's 1 over the square root of 9 plus 3, or 3 plus 3, which is 1 over 6. Rationalizing. If it is in the denominator, you will use the denominator. Whichever one has the root, you will use that one to rationalize. Okay, we talked a little bit about what happens when you plug in infinity, all right? And so when you have like just a polynomial function and you're plugging in like infinity or negative infinity, you're basically just trying to figure out, is it going towards positive or negative infinity, okay? So like they want us to move towards negative infinity here, right? So we're basically saying what happens to negatives, all right? So this is what I'm going to do with this one. I'm going to look at this first one. I have a negative to the third power. Is it going to be positive or negative? Negative, right? Then I have this guy, right? But it's going to be positive, but I'm multiplying by a... This is also negative, right? This is going to be negative, and then I minus 1, which is very insignificant. Like you have... All right? Yeah, we did a little bit of it yesterday. So basically, everything behind your highest exponent for these becomes somewhat insignificant. All right? These guys become insignificant because he is a huge number to the third power. All right? So you basically just look at your highest exponent when it's just a straight polynomial. My highest exponent is to the third power. I'm taking a huge number, negative, to the third power. It is going to stay a huge negative number. My limit here is negative infinity.
So you just want to know.
When it is a polynomial moving towards infinity, you're literally just figuring out, is it going to be positive or negative? All right? So let's look at the next one. I am moving towards positive infinity, but let's look at my highest exponent. It's here. So it's going to be positive, but it has a negative 1 in front of it. Everybody see that?
Yes.
What's my limit going to be? Negative infinity. All right. Let's look at the last one. Let's look at the last one. I am moving towards negative infinity. Let's look at my highest exponent group. It is to the fourth power. What happens when you take a negative to the fourth power? It is positive. This guy is moving towards positive infinity. So polynomials are very simple. You are strictly looking at your highest exponent and saying, what is this guy going to do? Right? What is this guy going to do? So go ahead and try A, B, and C there. So this one should have been negative infinity. All right, let's look at the next one. Negative infinity, but it is to the sixth power. So what is this? Positive infinity. This last one, it is negative infinity. My highest exponent is here to the fifth power. So what is this guy going to be? Negative infinity. These are just as simple. You do them individually, though. Think about what happens to the numerator and the denominator, and then your rules for division. Okay? So let's look at this one. We're going to positive infinity. Positive infinity. What's going to happen to my numerator? My highest exponent is this guy right here. We're going to a positive. All right? Let's look at my denominator. My highest exponent is this one. 8 times a really big positive number is going to be positive. Positive divided by positive is a positive infinity, right? Here's the thing. We have a positive infinity over a positive infinity. This looks like my rules. We had rules that we did in the last section, remember? What is the same here? We have 4 to the x over 8 to the x, right? What's going to happen to those positive infinities? It's the same number. What's going to happen to those numbers? They're going to cancel out, aren't they? Yeah? Does that make sense? So I have a 4 times this really huge number, and I have an 8 times the same really huge number. The 5 and 3 are insignificant. It's like if you gave, Elon Musk $5. He'd be like, I didn't even notice, right? Okay, so the 5 and the 3 are insignificant. The infinities are the same. They are to the same power, are they not?
Yes.
They're going to cancel out. What's my limit going to be?
1/2.
Yes, it is going to be 1/2. All right?
So what happens when you have a negative infinity over a positive?
It will be negative. It would be negative 1/2. Yep.
If it switches to positive?
If they're negative and negative, it would be positive.
Okay.
Okay, so
Let's look at this one. Let's look at this last one. I have an infinity on the top to the second power. So he's moving pretty big. But on the bottom, it is to the third power. I have these rules. What happens when my denominator gets bigger faster than my numerator? What is it moving towards?
Negative.
So my numerator is this small number. My denominator is this really, 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 really big number.
Going smaller.
What's happening to it? What are my rules? Remember my rules for asymptotes? When your denominator is bigger than your numerator, you're moving towards 0. Your limit here is 0. My denominator is getting exponentially larger than my numerator. Does everybody see that? So remember your rules. When your numerator is bigger than your denominator, we did not have one. So this is where you're going to have infinity. All right?
You said when your denominator is bigger than
When your numerator equals, you're going to use your coefficients, just like we did, the 1/2. And when your numerator is smaller, your limit will always be 0. Always. Always be 0. All right?
So when we're giving our answer,
So if it is the same exponent, if your highest exponent is the same, you're going to end up with a number. Okay? When your denominator is bigger, you're always, always, always going to have the answer of 0. Always. Okay? And when your numerator is bigger, it's going to be approaching an infinity. So let's look at that one. Oh, he keeps disappearing. Let's look at this last one. 5x to the 4th over 9x cubed plus 2x. All right, so in this case, normally we would say, well, the top's getting bigger faster, right? So we're not approaching 0 because my numerator's bigger, right? All right, but then what happens? We say, well, it's approaching infinity times 5. Infinity times 5. So then we're going to look at this guy and say, positive infinity to the 4th power times 5. And it's getting way bigger than my denominator, way faster. So we're just going to worry about him. 5 times infinity to the 4th power.
That's a big number.
It's just a really big number. All right? So when you have fractions, you're going to use your rules. All right? When the exponent on top is bigger, you're going to have either positive or negative infinity. When the exponent on top and bottom equal, you're going to have some number. It's going to be your coefficients. All right? Like we did 4 over 8 equaled 1/2. And when the exponent on bottom is bigger, it's always going to be 0. It's always going to be 0. Always. Those are your rules. Remember your rules for asymptotes? Those were the same rules. It's just you did not have an asymptote when your numerator was bigger. Now you're going to have an infinite limit. Where'd he go?